This is Software Engineering Radio, the podcast for professional developers on the web at se-radio.net. SE Radio is brought to you by the IEEE Computer Society and by IEEE Software Magazine. Online at computer.org/software.
Welcome to Software Engineering Radio. I'm your host, Jeff Doolittle. It's my pleasure to invite Davide Bedine as our guest on the show today for an exploration of Dapr, the Distributed Application Runtime. Davide Bedine is a cloud-native architecture enthusiast with strong and relevant experience with cloud platforms. As a cloud solution architect at Microsoft, Davide is responsible for the guidance and support of enterprise customers in embracing the cloud paradigm, a key enabler of their digital transformation. His recently published book, Practical Microservices with Dapr and .NET, helps software teams rapidly build cloud-native microservices by reducing or eliminating much of the boilerplate and plumbing, which are typically involved in building such solutions. Davide, welcome to Software Engineering Radio.
Hi, Jeff. Thank you very much for inviting me. Really excited to have this chance to talk about Dapr.
Great. Well, speaking of, what is Dapr and why should our listeners care about it?
Yeah, so Dapr is the acronym for Distributed Application Runtime. It's a project that originates from Microsoft probably a couple of years ago. So yes, we are celebrating these days the second anniversary. And so I started getting interested about Dapr since the very beginning. So even a small disclaimer, I'm not involved in the development of Dapr. I'm not part of the product group. I really consider myself as a professional enthusiast of Dapr. And so pretty much since the beginning, combining my experience as a developer and an independent software vendor before joining Microsoft, and also the experience I see with my customers, I immediately feel compelled to learn more about Dapr. So as a distributed application runtime, and the runtime from my perspective is one of the most relevant letter in the Dapr acronym, because it differentiates from a framework. So when you start to think about distributed application, multiple components which have the need to communicate, operate in a varied environments, you will soon face the need to have dependencies to frameworks in order to do any of the building blocks, any of the operation you are used to, whether it's managing state, having invocation between one component and the other. And so this is the area in which Dapr and the distributed application runtime aims to bring benefit to the users.
So when we begin distributing, there's unique challenges. And it sounds like what you're saying is Dapr is specifically meant to help address the challenges of moving from components that say run all together in memory with the same language and the same runtime. And now what we're doing is we're saying we're going to have a runtime that's going to allow us to handle a lot of those challenges of distributing components that are often left to maybe framework dependencies or maybe language specific dependencies, and maybe be able to detach ourselves from those dependencies?
Yeah. So this is really one of the objectives of Dapr, is to give you the ability to choose freely based on your architecture, your style, your languages, and also the frameworks, whether you want to split your distributed application in many or fewer components, because it will remove, as a runtime, it will remove what I would consider attacks on the need for your component to sustain over time a set of dependencies. So we can start, for example, with the ability of one component to communicate with another component, which Dapr provides a building block for, named service-to-service invocation. So if you have the same language in both components, which has been my past experience, well, this might not be that complex, but in reality it is much more complex. Because as you said, there are different languages, and each language might have a different framework. And these frameworks will have a different roadmap, and they will probably not move in sync in order to support that mechanism, remote procedure call or remote invocation framework in one language and the other. So it will get complicated.
Yeah, and that's kind of the tip of the iceberg, isn't it? I mean, as soon as you're communicating over something other than direct memory or maybe a socket or something like that, now you're going to have other issues like what about security? What about reliability and retry? I could go on, right? But I'm imagining these are the kinds of problems that Dapr is addressing, which have been addressed. But to your point, it's addressing them in a way that allows a breadth of access because different languages and different teams who maybe would have had trouble integrating before, it sounds like Dapr is intending to lower that bar to those different approaches and teams integrating their components together. Is that correct?
Yeah, absolutely. So in a sense, Dapr is not only a language agnostic approach to building microservices, because in the end, and these days, most of us are building architecture with microservices. It's also enabling future languages that have not been invented so far to support, because it brings the barrier of entry as low as an HTTP API or gRPC API too. But the overall point of Dapr is that it is a runtime that, using the sidecar pattern, lives side by side with your application. So if I'm starting to use Dapr in my local development machine, my sidecar will be another process. But when we speak about microservices, probably we are, and this is the destination I'm moving forward, we are speaking about container orchestrator or something like Kubernetes. So in that environment, your sidecar will be another container living side by side in the same pod with your application. So the HTTP API will be available to you in a very simple, consistent way, using standards wherever they are already available or established. And instead of frameworks, dependencies in your code, you will interact and you will be invoked by a sidecar working side by side with your application.
Okay. So let's make sure for listeners who aren't familiar with the sidecar pattern, I think maybe there was a little bit of description there of what it is, but maybe more explicitly, what exactly is the sidecar pattern? Because that's broader than just Dapr. So that's a pattern Dapr's adopting. So maybe give us a brief overview on what the sidecar pattern is.
Yeah. So when we think about, let's say, even locally on a single box, you can have a piece of code working inside of your process. Okay, and this happens when you load a library from a framework. And so that code will execute inside of your environment. So you share some of the dependencies with that framework. You are running, let's say, your language of choice is Python. Probably you're using frameworks built in Python. And probably you have to get to a certain alignment on the versions. So something that you can do with Sidecar is to split the overall application, your code, for example, from whether it's a common function, a common feature that you want to provide to all of your application, or rely on another component, a third-party component, and you make it run on another process separate from yours. And so in this situation, you have many advantages. One is that the resources in your processes are only used by your code, your application, and that anything that happens in the two the two sidecars, your application and the one that you're using, does not influence the other. But it's more about the separation of responsibility and expectations. So the way to be able to interact between one sidecar and another could be various. Dapr choose to implement locally reachable API. So going back to the example of running locally in your development machine, you know that localhost, the default port, which is 3500, you will reach the Dapr sidecar process for that you have instantiated for your application. And pretty much the same with certain level of change will happen if instead of your local machine, you are running into a pod in a Kubernetes cluster.
So the service that I'm dependent on, I'm really dependent on this middle piece, this sidecar that stands in the middle between me and the other service that I'm dependent on. And then decisions about whether I'm accessing that locally or remotely are encapsulated within how I configure that sidecar. Yeah,
that's pretty much the concept. And the goal with Dapr is that if your distributed application has, let's say, two components, each component will have its own sidecar. So if I have component A that it's written in .NET and component B is written in Node, they will both communicate with their own sidecar. So let's say I'm in my local environment, I'm going to have each of my application, my component will have its own sidecar. If I'm running on Kubernetes, component A and component B will be separate pods. Because this way I will, for example, be able to scale it independently. Okay. So what we were used to do with VMs, we probably placed component B on a different kind of CPU of VM with maybe more or less resources, and maybe we scale this way in the very old days with container orchestrator engine like Kubernetes. You accomplish pretty much the same goal, having multiple pods of the same component running and dealing with all the requests. So this is pretty much how Dapr relies on the sidecar pattern in order to give you the ability to interact with any other application, regardless of their language, regardless where they are located. Could they be in the same node where your application is located? Could it be in another node? And most of the time, it will be on a separate node. It will not influence the way you write application, because you will still have the sidecar at your disposal that you can reach with an HTTP API. So every language is able to use, to interact with an HTTP API.
Right. So it's something I said before on the show, and I say it a lot for people who know me personally too. The two hardest problems in computer engineering are information hiding and dependency management.
Yeah.
And really, to say dependency management in a way is to say information hiding, which I could get into another time. But you've mentioned dependency management and things already, and I think it's relevant here too that if I'm using the sidecar, I'm able to hide a lot of information about what's happening behind the sidecar on the other side of any components or services that I need to be able to interact with. And that isn't to say I don't worry about them. Obviously, as soon as you distribute, you're going to have to deal with latency and retry and things you wouldn't necessarily have to locally, but you can make those decisions in how you configure the sidecars. And now it sounds like Dapr is trying to address those major issues, information hiding and dependency management.
Yeah, absolutely. And so far, I mentioned the service-to-service invocation, which is a building block, one of the 7 building blocks of Dapr. But the value in what you are describing is more evident when you switch to state management and the publish and subscribe, which are two building blocks. Because with state management, well, we could probably have a 1-hour talk on just state management, but to keep it very simple and short, let's say your component has the need to keep some state aside, so your code can be simpler because it will be a stateless service and your state will be handled by someone else. So you're shifting one of the difficult responsibility we tend to have in distributed application, which is to keep state between different calls from the same client. So with state management, the responsibility will pass to the Dapr sidecar, but then starts probably the value in the extensibility of Dapr. So Dapr comes out with probably then more than 70 components already available and other coming up being built by the community in order to store the state in different services, whether it's Redis cache, whether it's CouchDB, or a cloud vendor operated database as a service. So Dapr does not only have the aim to be language agnostic, but to be platform agnostic. And we mentioned Kubernetes, we mentioned local environment, which are the two deployment options, but it's also a cloud vendor agnostic. So if you go to the documentation of Dapr, you will see that for state management, but also for publish and subscribe, you will have support for many of the services provided not only by Azure, but also by the other cloud vendors.
Okay. So you mentioned building blocks, and I get the sense that that's a pretty important element here. And you said there's 7. We don't need to list the 7 necessarily, but previously to the show, you mentioned that there were a few core building blocks. And so state management is clearly one of them, as you just mentioned. Yep. And is there anything else on state management that's worth mentioning before we maybe dive into a few of the other core building blocks?
Yeah, absolutely. So the concept here is that you code your component counting on the availability of the API by Dapr on the sidecar. So you can interact directly. You can use an SDK for pretty much any of the language available today and present in the market. But the choice on whether you're placing the state on an Azure Cosmos DB or as you are local, you're running it locally on Redis, this does not sit into your code or your code configuration. It's a component defined in YAML format, which is pretty common to everyone that has to deal with Kubernetes. And I mean, not that they want to deal with Kubernetes, but they have to deal with it.
Yes.
So it's something that will be decided whether by you, whether by the operation team. You will be able, via configuration of components, of Dapr components, to switch your application from running local to running natively on Azure by just changing a component configuration. And this applies to all the other building blocks. So okay. The next one probably publish and subscribe, I think. Service to service, state, and publish subscribe are probably the one that you use the most time.
Okay. So service to service, basically meaning I have one service, I know what service I want to call, and now I'm going to call that other service. Now, I imagine the sidecar is going to help me with dealing with the location of that service so that I'm not coupled to that as the caller. But the interface of that service is what I can depend on. Is that a fair assessment?
Yeah, so Dapr does not intervene in the definition of the payload you are going to pass to the other component because it has an opinion on how to build distributed application, whether with microservices architecture but it leaves to your language, your choices, your framework, how to deal with the payload. What you have to specify with service invocation is the name of the other component in the Dapr ecosystem, and then the method you are going to call to the other side. And so your request from your sidecar will go through the environment. On Kubernetes, it will use the Kubernetes mechanism to find the corresponding services, which you will not have to care anymore about, and will pass the payload to the method you specified. So between your component and sidecar on both hands, it can be HTTP to keep it simple, very easily readable. You can also use gRPC if you have the need. But the great thing is that between the sidecar of Dapr, which, as I said, can be distributed over many different nodes, communication will happen in gRPC and will be secure with MTLS. So you get many benefits by default by just interacting with a simple HTTP API.
You just mentioned a new one there too, which I think is important to highlight. You mentioned MTLS, which is Mutual Transport Layer Security. And so I believe that's the correct, and we'll put a link to that in the show notes in case I'm wrong. And even if I'm right, you still might want to look that up. So I'm also getting, I want to say, quote, for free. Nothing's free, but I mean, to me, I'm not having to implement now transport layer security between my components. Dapr is giving that to me?
Yeah, in Kubernetes, there are a number of Dapr system components. One of these has the responsibility to give the ability to any Dapr sidecar to establish mutual secure channel of communication between each other. And so, yes, you get MTLS as a feature of Dapr.
And then once you have control sort of that pipeline of communication between two components, and since now you have this runtime and these sidecars between each side, you can pretty much manage that pipeline by adding whatever. I mean, it feels a lot like middleware with a mediator pattern, sort of like if you're, doing, Spring apps, or you're doing applications with ASP.NET Core, you can inject middleware into your pipeline and do pretty much whatever you want at that point. It just sounds like that brought to more of the service to service, application to application level.
Yeah, absolutely. In a sense, it's really as you described. And something I recently experienced. So I had the chance to have a hackfest, as we call, with a customer about Dapr. And it has been mainly run on another language that I'm not familiar with. So I was a bit worried that, being a .NET developer, in the past at least, my focus is always looking at, the SDK, what the SDK provides. And so my worry was, but what if the corresponding SDK for the other language does not match the libraries, the frameworks that the customer was using? And not for this preference over using this SDK or not with Dapr, but as an experiment, we chose to run the Hackfest by interacting directly with the HTTP API of Dapr. And so this customer had their language, their framework, which was used to pass a lot of data inside the payload or as headers. And we really did not have to touch anything because, as I said previously, Dapr doesn't mandate what you put in the payload and in the headers you pass. And so it has been kind of eye-opening for me that I consider I spent a lot on Dapr to see how easy it is to, I don't want to downplay with easy, but how efficient it is to insert Dapr into an existing framework that might do things in a way that is different for me, for example, to what ASP.NET does with all the attributes and the ASP.NET framework.
Right. So you were able now to integrate with services components written by this other team without having to first understand their language, their framework, their development tools, everything about, their build chains and pipelines and everything. Instead, you were able to consume it and interact with it using Dapr, and then vice versa, you'd be able to deliver something to them in the other direction as well. So that sounds really powerful. And with
yes, it is.
Yeah. So taking that now and moving to the next building block you mentioned before, which is publish and subscribe, which basically is one service is sending out a message and it doesn't necessarily know, it really shouldn't know who's listening, but other services can subscribe to those messages and receive them. So talk a bit about that and how Dapr implements publish subscribe in a way that's maybe different or an improvement on typical approaches.
Oh, yeah. And so with the publish and subscribe, as the goal of Dapr is to offer a consistent set of APIs, from the API perspective, it doesn't change a lot. So instead of invoking, you are publishing a payload. But this is one of the building blocks in which I speak from my personal point of view. It gives a lot of sense to observe your existing approach to the publish and subscribe, and maybe think about if even inserting Dapr and substituting the way that you deal with sending and receiving messages with Dapr gives you value. I think it will really give you a lot of value and a lot of help, because it will transform the way your components, your microservices are listening to events to a complete event-driven approach. Because, so I spent a lot of time with Azure Service Bus and other technologies. And so each one has its own way of dealing with the consuming of messaging, whether it's by looking at the content and then deciding whether to process or consuming directly by reading. Each one has its own approaches.
Sure. And example like RabbitMQ or SQS, right? They're all unique in some ways and respects.
Yeah, absolutely.
Right?
Absolutely. Yeah. Also because they have different history, different use cases from which they originated and grew. So all great reason to be different. But if you are creating a new greenfield distributed application, or you want to innovate on an existing one, the fact that there is a sidecar side by side with your component that is being configured to use on Azure, let's say Azure Service Bus, and maybe RabbitMQ if you are working locally, or you have an on-premise installation of your solution. And counting that it will be the sidecar responsibility to properly use in the best possible way the libraries for consuming these services. And you will not have a different approach in your code to react to messages coming from Service Bus or RabbitMQ. It will be the same, because your approach will be event-driven. Because in fact, the sidecar will ask your component first if you are interested into subscribing to any topic that is exchanged in the messaging, in the publish and subscribe building block. And it will ask for the endpoint that the sidecar has to call to inform you that a new message or event has been received. So you will simplify a lot. This is really helpful from my experience and the perspective I have during these days working with customers.
Yeah, and something you said I really appreciate as well. And it's come up before. You've mentioned development locally versus directly against cloud resources and assets. And I'm a huge fan as much as possible, and I push it pretty far if possible, to do development entirely locally. Because when the internet goes down or GitHub goes down or whatever else goes down, especially if you need, I can't get to SQS because my AWS cluster is this or that, or my Kubernetes cluster is once again, on the fritz. It's like, well, hold on, I can do everything locally. And that ability you just described, I'm not going to run a full, SQS instance locally, although I'm aware that there's solutions for that. And it escapes my mind right now, but there is a project that's a stand-in for a lot of those Amazon cloud services, and I'll find it and put it in the show notes. But I can also take a different tack, which is I can run RabbitMQ locally, but I can be confident that I'm going to get the same behavior out of Azure Service Bus when I switch it over to the cloud. There's a ton of power in that. How is Dapr doing that behind the scenes? How in the world can it, manage this? It must be doing some sort of magic or using some other existing tooling to pull this off?
Oh, no, nothing magic.
Okay.
So Dapr, well, I think it's really, I sometimes also think about, this can be true, how easy it is. But usually it pivots very fast on why I didn't had it before in my life. But this is a completely different story. And so Dapr is an open source project and is written entirely in Go. Okay. So it relies on the components for each of these technologies, the 70 more components available, by using the corresponding Go library for each of the service. So you have right now a large community that is using the same software you are using from different perspective. So, and knowing that your client library, client to the messaging subsystem, the messaging system of choice, that is being used on different setup, different scale, different languages, but it's the very same library. Well, you have probably more cases than the average that gives you the trust that someone else will see the way to improve it and to update the component. Or if you have a compelling need, you will choose that it can be you as an individual, as a component, a customer, to become a contributor to improve that component for the benefit of the overall community.
Sure, but what about actually running this stuff? I mean, I imagine I need to download some things to get started, and then I say, okay, well, I want to run these things with these versions of, say, messaging or state management, but then in the cloud, I want it to be these things. What's happening locally in order to enable this all to happen? Is Dapr doing everything itself, or is it relying on something else?
Yeah, so the configuration happens via configuration files. Mm-hmm. So they will influence which of the many components for each of the building blocks you will choose to use. And from that point, you will have the ability to influence the way each component works by injecting specific configuration. So with Service Bus, you have the option to configure some settings that might be different in RabbitMQ, but this difference will stay in the component definition.
Right, based on whether it's local or cloud.
Yeah, absolutely. Or the configuration.
Do I have to install all of these dependent services myself locally?
It's something that will happen during the initialization of Dapr. So whether it's local, you run Dapr init once you install the command line interface, or if you are in a Kubernetes environment, you can do the same, or you can use a different approach, which is an Helm chart, and you specify which version of Dapr you want to run. And this will place the system components and the code that will be used by the possible configuration of your components. So it will be the sidecar in a sense that will carry the options for, let's say, use RabbitMQ, use Azure Service Bus for the publish and subscribe, or use this or other database for the state management.
Okay. You mentioned something before. I want to make sure that doesn't just fly by. You said the words Dapr and NET. So DAPR space INIT, which refers to the Dapr command line.
Yeah.
So maybe speak to that a little bit.
Absolutely. So the Dapr command line interface is a tool that you can install on any box that helps you with the development experience. Locally, you will use Dapr to run an application with Dapr run, and you will specify the name of the application and the other settings. You will not use Dapr run once you run your application in Kubernetes, because in that part, it will be someone else's responsibility to start your pod with the container of your image. On Kubernetes, it's as simple as injecting some Dapr-specific annotations into your deployment YAML file, because YAML gets everywhere. And so if you have your application and you have been able to put it into a container and you want to run it on Kubernetes, it's highly likely that you already have an existing YAML file describing how your application is going to start, which port does it use, etc. But what you just need to do is to inject some Dapr annotation in this file, and there will be no other requirements other than this in order to let Dapr know that your container has the interest to interoperate with Dapr. And so Dapr will inject the sidecar into your pod automatically without you as the developer to deal with all these configurations.
So you mentioned container again, and I think that's pointing to, let's say I want to install the Dapr command line interface, which I can go find, probably just, do a web search for DAPR space CLI. And you mentioned I can pretty much run that anywhere. If it's using containers, then I imagine I'm also going to need to take a dependency on some engine for running containers locally.
Yeah. So locally, well, not necessarily, because locally, by default, Dapr installs the Redis just in order to give you a very easy and fast chance to run Hello World, a very simple application locally, and also does install locally one of the components of the system components of Dapr, which is the placement service, which is necessary for another building block, which is the actors. But you have the ability to install Dapr also without this component. And so locally, for example, in my book, what I instruct or teach the reader to do is to use Dapr run to run the .NET solution, the .NET projects directly in the VS Code environment. So in that stage, while I'm in the development phase, I'm not already putting all of my code in a container deployment option. I'm just telling Dapr to run side by side with my .NET application. So in that part, there are no containers involved. Containers are a very good way to deploy an application to Kubernetes. And so from that point, you will have to deal with containers. But if Kubernetes is one appealing compute option for your application, you already approach the good and the complexities of putting your application into a container.
Okay. Yeah, that's great. And back to something you said before, those 3 services that you're going to automatically get when you Dapr and NET and Dapr run. So you're going to get Redis immediately for state management and for PubSub. Now, of course, keep it in mind, this is, if you need persistence, you might need to reconsider, but at least for getting started, you're building application code. And so now all of that infrastructure, you can sort of say, I'll get to that later. First, I want to get my application code working, and then we'll get to the actor building block later. But basically, now I have these 3 services running that are giving me access to these Dapr building blocks with no additional configuration or work on my part. I can just start writing application code.
It's really just default configuration that you have on your local machine. So once you run Dapr init, by default, you will have 2 YAML configuration files that that have been provided by Dapr that points to the local Redis container. So if you install Dapr init, you will get just as a starting point Redis, but there is not a requirement to use Redis even locally. Because as we speak, also because it's my experience, I tend to consider the local experience, the development experience. So I heavily rely on Redis just to test if I'm able to run my components, if everything is fine, I use it as a test. But there might be situations in which you run Dapr even locally, even on VMs, but you will not rely on Redis. You will rely on RabbitMQ and maybe Mongo, Couch, whatever other local database option you have with persistence, obviously. It's really just a way to ease the experience of the developer just after you run Dapr init.
Okay. So we have those core building blocks, service to service, state management, publish and subscribe. And then I think where we start to get to another level of power is the building blocks called bindings. And in my research for our interview today, it kind of occurred to me that in many respects, Dapr is enabling what's, been called the hexagonal architecture pattern, which I'll put a link to in the show notes, which basically it boils down to ports and adapters. And so you're back to information hiding and dependency management. The canonical old school end-tier application was the database is sort of at the bottom layer, and then everything stacks up above that. But you end up getting this nefarious coupling because the data access layer gets coupled to the database, your business layer gets coupled to the data logic, your front end gets coupled to the business logic, and you really haven't solved anything. You've just made a distributed mess now instead of a monolithic mess. And so now what we're saying is flip that around. The database is outside, your hexagon, if you will. It's something you bind to, as we'll discuss here, or whatever these other things are, right? You have ports into your system, you have adapters out of your system. So talk a little bit about bindings and how they can kind of help us with that notion of, instead of having these dependencies leak up through our systems, instead we put them outside so that we depend on them in a decoupled fashion.
Yeah, absolutely. So if we consider the other building blocks for comparison, so with service-to-service invocation, you gain the ability to establish direct communication between 2 components. One knows the existence of the other. With publish and subscribe, you are still establishing a relationship with 2 applications. What changes is that the subscriber is probably unaware of the existence of the publisher. It just knows that having expressed interest for a message for an event, depending on what you consider, he will receive it, and with this event-driven approach, it will react to the information. And so these are 2 ways to have your components in your Dapr application to work together. What I consider the bindings, the input and output binding, is a way to extend your application to the outside world, to something that is already there, like enterprise event streaming platform that has been around for far longer than your application, and it will stay a long time there. And you want, as your application is getting built, you want to consume events that come from that source of information. And so the messages that you will receive, they are sent in a generic way. There is nothing specific about Dapr in the way that you will find messages streaming in a Kafka stream or in Azure Event Hub. You will configure an input binding in a similar fashion to what you do with publish and subscribe, but it's meant to be a way to reach to outside of your application, integrate with an existing flow of information. So, because what I forgot to mention is what gives you Dapr, for example, in the publish and subscribe, is that by using cloud events, it enables full end-to-end visibility for observability, which is another building block, because it inserts metadata. So whether your application internally between components at one time is using service to service or is using publish and subscribe, the way that they will share traces via observability and by leveraging another existing standard, which is OpenTelemetry, they will look pretty much the same. In reality, it will be a different approach, but they will look at component A and component B interacting at different times in different ways. Once you consume a Kafka stream from another system, you will consume messages as they are. And if you want to give back to the messaging platform, the enterprise service bus or whatever you want to name it, you will send raw payload without enriching them with anything that is not Dapr specific, but is more closer to your application. So and streaming of event is just an example. It can be consuming events from Twitter, which is one of the first example you find when you go to dapr.io or docs.dapr, because it tells the story of binding. But, it's just an external system that is not necessarily part of your application. It's another application or something really outside of even your enterprise, your company. And you want to find a similar way with component configuration to consume events from it and react to events from it.
Yeah, and you mentioned something important I want to make sure we highlight, which is you mentioned cloud events. And that is a really important thing to mention because cloud events is part of the Cloud Native Computing Foundation. Short form is the CNCF, which we'll put a link to all of those things in the show notes. And am I correct in saying that Dapr is also part of the Cloud Native Computing Foundation?
So what I know is that the process of integrating, automating the project has been started. It's a public process. I'm not familiar with the current status, but if you go to the Dapr roadmap, which is publicly available and on GitHub, you will see the current state of the affair. Okay,
so it's incubated as a CNCF project. That was what I recalled, but it isn't necessarily in it yet. But that process is going. And as you mentioned, it is open source. But also then embracing open standards, I think, is kind of the deeper story there, that Dapr isn't just reinventing the wheel on a lot of these things. It's adopting what is there as existing standards as well.
Yeah, and this is one of the core principles of Dapr, is to really use standards wherever they are available and have traction in the community. So we just mentioned cloud events. The other one is OpenTelemetry. And so instead of inventing something new, I think we all agree that it is beneficial to everyone to contribute back to the success of an open standard, an open platform by using it, for example. And so this is OpenTelemetry, for example, is something, and the observability building block is something that I would have really treasured in my past, but really it was not around, even the concepts. And so I had to build my own stack to have visibility of a request going through many components. And sometimes I had to make choices on whether it made sense to split one larger component into two because the roadmap was diverging for one part of the features from another one. So it was one healthy discussion about should they be two different components or two different microservices, but having something more, one more component to handle, to manage, to bind to the login stack I built myself, it influenced the discussion.
Yeah, it was a limiting factor in a way that you didn't really want that. There's always going to be limiting factors and constraints, but that's not the one you wanted. And so now we can take a different approach. You mentioned observability, before we move into that, so bindings, you did mention things such as other enterprise services or things that are not Dapr ready. But I also want to make sure we hit as well on the other side of bindings, which is, say, for example, connecting to databases, and maybe make a distinction between when would you use state management, which we talked about before, versus when would you say use bindings to a database instead of state management?
Yeah, absolutely. So with state management, Dapr aims to give you the ability to take the burden of keeping a state outside of your component. So your code can be written with a stateless approach. And that's the value of that component. And by doing this, it doesn't affect your payload, but it adds some information to the overall payload with just some decoration. But in a general sense, it will leave it as it is. But it's something specific to the state. And the API are as simple as it's needed for a state management. It doesn't provide a full query language. So you are meant to just keep the state between calls and nothing more than this. You will still have your database, your line of business, and long-lasting database.
Right. But the state management is more like key value store, it sounds like. It's just in and out.
Absolutely.
Yeah, absolutely. As opposed to bindings, maybe. Yeah, now expand on that a little bit for us, what the distinction would be there.
Yeah. And so with bindings, you have the ability to interact with another system by just sending and receiving a raw payload. So I don't remember which are currently the database supported as both whether input and output binding. I suppose mostly as output bindings by Dapr. But yeah, the sense here is to pass an information to an external database without any influence on what you are managing.
So you mentioned observability as one of those things you wished you had. And I think a lot of us have been there. As soon as you choose to distribute, you find the pain of the lack of observability if you don't have it. So Dapr obviously adds this as a building block. And you mentioned before OpenTelemetry as well. So speak a little bit more to why observability is so important in a distributed application and how Dapr lowers the bar to getting observability.
Mm-hmm. Yeah, so as you said, immediately as you create two components, as you split your application into different pieces, you will have far more interactions going through less reliable communication channel than being inside the same process. So you never account for faults and retries or intermittent transient errors when you interact with a library that you load into your application. But As soon as you go outside of your process, and far more relevant, as we are considering Kubernetes as the major compute option for microservice-oriented architecture, you will cross also the network boundary of a VM or a node in Kubernetes terms. And this will increase the number of situations that your application has to deal. So, and this is just for service-to-service communication. So when you start sending messages to messaging system with the publish and subscribe, it will happen at different times on different nodes maybe. So it will not even be in the same sequence of events. So this is another complication, which will happen regardless of the choice you make on your framework, your language, etc., because they are part of the reality of running a distributed application. And so with observability building block and by adopting the open telemetry, you out of the box with just one configuration, which you attach to your Dapr application, you can specify your application to enable the forward of all the traces to a consumer, compatible log and metrics consumer, compatible with the OpenTelemetry stack, which will give you an end-to-end visibility of all the interaction that happened, regardless of the way that you are using the Dapr API. So if your components just leverage Dapr for some of the building blocks, let's say state management and service to service, these are this exchange between one Dapr application and the other, and the retrieval or update of an information with the state. These are the elements that will surface via OpenTelemetry and that you will be able to see from any viewer, let's say any consuming application that can deal with that format, that open format. So Zipkin is one option. Application Insight can be another one, but also other tracing, application performance monitoring, tracing and logging platform can be used. So it's highly likely that you will be able to integrate it, your existing platform with Dapr, because OpenTelemetry is a standard. So it's not something magic. It's just that it's a standard, and so everyone in the industry is embracing it. And so this is an incredible value from the operations side, but also from the development side, because you know that once you get an exception and there is a trace ID, you as the developer and the operation team will be able to see the very same trace, the very same exchange, knowing where it's taking too much time, how the code is flowing. So it's really helpful development and optimization and operational asset you gain with Dapr.
Yeah, troubleshooting bugs, but also root cause analysis on outages or things of this nature. Absolutely, having that ability to do distributed tracing is important, and so that's great that Dapr includes that as a very important building block. So I want to get started with Dapr. Let's say I have an existing application, and I don't want to have to do a bunch of rewriting, redos, whatever. Like, how can I get started using this on an existing system? Obviously, for Greenfield, it sounds like there's a lot of power here and things I can do, and that's great. But it's always super important to make sure that the new cool things don't just leave everything in the dust, because we can't just rewrite everything. So how do we get started with Dapr on existing systems?
Yeah, absolutely. So I don't know what's your starting point, but I tend to look for SDK wherever I can, but this just because it's my background. But as I said, even for Greenfield, for a new application, SDK is provided by Dapr for all the language is a starting point, because it accelerates the development. But one option is to use Dapr directly with the HTTP API. And this is the approach that you can take to Daperize, which is a term that is used in the Daperize, yeah, that is used in the Dapr community, which means to enable an existing application or even a new application to interact with Dapr via the API. So yes, your application must have a way to request and send something to an API, but it doesn't ask anything more to the existing application. It doesn't have to know about Dapr. And probably one of the first scenario that you face on Daperizing an application is, which is also very well documented into the docs Dapr site, is on instructing an ingress controller, which is a component in Kubernetes, which you use to expose your application that is running internally into the Kubernetes cluster. You use it to expose it to the outside world, to your customer, to your clients. Okay, and so what developers had to do was not only to configure, to put their code into a container and then configure a deployment specification YAML, but they also had to deal with services from the Kubernetes perspective, how to discover application, how to name application, etc., which is taken now care by Dapr. But by Daperizing, you just inject some annotations into a deployment script. So you can do it with Nginx as an example, but any other ingress controller, it applies the same. And so if your application has a way to request to reach the resource via an HTTP and maybe do some translation, you will be able to use Dapr. And it's something I recently experienced in a scenario that we went through. We chose to take this approach of Daperizing an existing application that for sure already had a place in which it was possible to change the address, the URL of the resource, of the endpoint, and we changed it from the existing one with a Dapr-specific API endpoint pointing to the sidecar. And so as nothing is mandated about the parameters, the headers, the body, etc., everything gets passed as you put it. So with an ingress controller, going back to the well-documented sample and something that I also went through in my book, it's really easy given that you already deal with HTTP API.
Right. So if I have one service that is reliant on another service, and let's say it's already communicating via HTTP, then I can basically, instead of having it speak HTTP to the existing endpoint, I can have it talk to the Dapr sidecar and then have Dapr now become the mediator between my service and that other service. And then I can leverage all this other richness, like the observability that we mentioned before and everything else that Dapr can provide. So that's one way to do it. There's also, in my research, I found a project called Dapr Sidekick, which sounds like it takes what you're describing and it lowers the bar even further. Are you familiar with that project? And maybe if you are, explain a bit about what it does.
Well, I'm not that familiar, but it's something I really remember from one of the community calls, which I attend as many in the community. And so Dapr has bi-weekly community calls. We open for everyone. So Dapr also has Discord channels in which you can talk about all the components, in addition to the proper discussion on GitHub. But in the community calls, there are many contributors, like in this case, Sidekick is a project started by Man Group, in which they presented a new way to leverage Dapr or for deploying an application, not obviously on the local machine as we started our conversation, not on orchestrator like Kubernetes, but on multiple VMs. And so they extended the way you can operate the Dapr sidecar in a way that enabled them to rely on Dapr for the various building blocks in a new scenario, which is from my external perspective as someone that is closely looking and loving the community and the Dapr project, is something expected, absolutely, but nevertheless is amazing. And it's something .NET specific, if I remember.
Okay, I think you're right.
Maybe we can put in the notes also the pointing to the community calls, the specific one in which they talked about this, because also the process. So far, I have been successful in a way to build something with Dapr, but that example and many others are relevant also to understand on how can you build something new that did not already exist with Dapr, support new scenarios, and contribute back to the community, which is something I have not been able yet to do.
Well, except you did write a book, which is introducing people to the technology. I'd say it is, in a sense, that's definitely a contribution to the community.
Have you ever really been happy with your project management tool? Most are too simple for a growing engineering team to manage everything, or too complex for anyone to want to use them without constant prodding. Shortcut, formerly known as Clubhouse, is different though, because it's worse. Wait, no, we mean it's better. Shortcut is project management built specifically for software teams. It's fast, intuitive, flexible, powerful, and many other nice positive adjectives. Let's look at some highlights. Team-based workflows. Individual teams can use Shortcut's default workflows or customize them to match the way they work. Org-wide goals and roadmaps. The work in these workflows is automatically tied into larger company goals. It takes one click to move from a roadmap to a team's work to individual updates and vice versa. Tight VCS integrations. Whether you use GitHub, GitLab, or Bitbucket, Shortcut ties directly to them so that you can update progress from the command line. The rest of Shortcut is just as keyboard friendly, with their power bar allowing you to do virtually anything without touching your mouse. Throw that thing in the trash. Iterations planning. Set weekly priorities and then let Shortcut run the schedule for you with accompanying burn-down charts and other reporting. Give it a try at shortcut.com/SERadio. Again, that's shortcut.com/SERadio. Shortcut, again, formerly known as Clubhouse, because you shouldn't have to project manage your project management.
This has been a fascinating overview, and I'm sure listeners are aware that this is really the tip of the iceberg. And if they want to dig deeper into Dapr, I mean, we didn't really have time to get into two of the other building blocks regarding secrets. You know, you mentioned observability before as something that you always wished you had. And now, you know, I would say secrets management is another one of those that a lot of us are always ripping our hair out about. Like, why is it so hard? And it's getting easier, but still. And then also the actor building block is so powerful. We could honestly probably do a whole episode on actors and how Dapr enables actors. But I definitely want to encourage listeners to check out Davide's book. You mentioned the Discord channel for Dapr, and there are other books as well. And there's the community calls related to Dapr for those who want to get involved. And just a reminder, this isn't a Microsoft or a .NET thing, although that's sort of its genesis. But Dapr is written in Go. The building blocks are written in Go. And there's lots of contributions from lots of different communities, which really bears a lot of promise for the future we want to have, which is teams can use the toolings and languages they're familiar with, but adopt standards for interoperation with other services. And that sounds like a future I want to be a part of.
Absolutely. And keep using the language they want, they prefer, they need, the frameworks they need. And also, so be language agnostic, but also be able to offer to your customer, to their customers, an application that can run everywhere, because the world is getting more complex. the edge is playing more and more important role. So probably I tend to think as the local environment as the development environment, but the edge, and as Man Group demonstrated with the Sidekick project, it can be even more rich, even outside of a Kubernetes environment.
Absolutely. Well, in the book, there's a GitHub repository with code examples and walkthroughs for our listeners as well. But if listeners want to find out what else you're up to, where can they go?
Yeah, you can find me on Twitter and on LinkedIn. My alias on Twitter is Bedin Davide, and same on LinkedIn and Dev2. And absolutely ping me if you want to know something more about Dapr. But I encourage to go to dapr.io, which is the starting point for Dapr, and then read the documentation on docs.dapr.io and start from there to learn more about this rich new runtime.
Well, Davide, thank you so much for joining me as a guest on Software Engineering Radio.
Thank you very much. It has been a pleasure. Thank you.
This is Jeff Doolittle for Software Engineering Radio. Thanks for listening.
Thanks for listening to SE Radio, an educational program brought to you by IEEE Software Magazine. For more about the podcast, including other episodes, visit our website at se-radio.net. To provide feedback, you can comment on each episode on the website or reach us on LinkedIn, Facebook, Twitter, or through our Slack channel at seradio.slack.com. You can also email us at team@se-radio.net. This and all other episodes of SE Radio is licensed under Creative Commons License 2.5. Thanks for listening.